Good morning, everyone. Today we're going to talk about continuous functions. By the end of this lesson, you guys will have some insight on about this topic. Our objectives here is to talk about the fundamental concepts, how to identify graphs of functions that are continuous, to know the conditions if the function is continuous or not, some examples of continuous and discontinuity functions, and some application problems. Okay, so the fundamental concepts. There are three main fundamental concepts you should know about. They are the existence of limit, continuity, and differentiability. So, how can you identify continuous functions just by looking at it? First, you can tell if a function is continuous if there are no breaks in the graph. Second, every point in the graph is connected by a single line. Here are some examples of functions that are continuous. As you can see, there are no breaks in the graph, and the graph is connected by a single line. A function is continuous as a number x is equal to a if the following conditions are satisfied. F of a is defined, limit of f of x as x approaches a exists, and limit of f of x as x approaches a is equal to f of a. Okay, let's look at this first condition. For a limit to exist, the left side limit must be equal to the right side limit. Limit of f of x as x approaches from the left side should be equal to the limit of f of x as x approaches from the right side. The second condition is when f of x is defined at x is equal to a. And the third condition is when limit of f of x as x approaches a is equal to f of a. What is true about the graph y equal to hx given that limit as x approaches -1 from the right is equal to limit as x approaches -1 from the left is equal to 1, and f of -1 is equal to 1. So we can tell without plotting a graph that the function is continuous if it satisfies all these conditions. And here's how. All these conditions must be met for the function to be continuous, and if they are, then the graph y equal to hx is continuous. Now let's switch gears and look at a graph. Y equal to f of x at x equals to 2. So in this graph, all the conditions are met, as you can see here. So you can say that the graph y equal to f of x is continuous at 2. Now let's look at discontinuities. The first discontinuity is removable discontinuity. Removable discontinuity is the only discontinuity that has a limit. This is a graph with a removable discontinuity. So the graph y equal to f of x, limit as x approaches 2 is equal to 1, f of 2 is equal to 1.5, limit as x approaches 2 is not equal to f of 2. So the graph is discontinuous. The second discontinuity is the jump discontinuity. As you can see in this graph, the graph does not have a limit at x is equal to 3. So the graph is discontinuous. The last discontinuity is the infinite discontinuity. As you can see in this graph, the graph does not have a limit. This is because the limit is not getting infinitely close to any number. So we can say the graph is discontinuous. So to recap everything here, a function is continuous if and only if limit exists at x is equal to a, function is defined at x is equal to a, and limit at x equal to a is equal to f of x at x is equal to a. We have
created using Powtoon.